All right, so our unit 2 is titled Transformations in the Coordinate Plane. So we're going to talk about transformations, and you have talked about these transformations before. I think it was in the 7th grade math. So before pre-algebra, you should have talked about these transformations. So today we're going to talk about translations and reflections. So most of this is a review, which is kind of nice. But we'll add a little bit of a extra geometry flair. So I have some vocab. So things to note. So these are my notes that I would have done if we were together in class. These are on Canvas if you want to see them, access them, print them, whatever works for you. But we do have some vocabulary. So we have a transformation is a movement of all the points that make up a geometric figure according to the same rule. So this is kind of important. So I'm not going to multiply the x by 2 on one point and by 3 at another point. The pre-image is the original figure and the image is a transformed figure. And then rigid motion is a special type of transformation that preserves shape and size. So we talked a little bit last week about congruence. So this figure, which is equal with a little squiggly on top, means is congruent to, which means that all of the side lengths are the same measure and all the angles are the same measure as they appear. So geometry, we do a lot of notations. So if I start with the pre-image point, I will call it A. When I move it or transform it, I call it something different. I call it A prime. So this apostrophe is prime, is how I would say that, A prime. Now, if I take a pre-image and I transform it to A prime, and then I'm going to take A prime and do another transformation. So later on, we'll be doing like multiples. Then I will call that A with 2 apostrophes. So this is a, probably should use an arrow, double prime. So it just shows that I started with some point A. We don't want to rename it because then we'll end up with a lot of letters and I won't know which one goes with which one. So same letter, I just add a prime every time I transform it. So if I have a triangle, let's say triangle ABC, and I'm going to do some transformation. I'll call it triangle A prime, B prime, C prime. And since my pre-image is congruent to my image, I have 3 sides of my triangle. So I have side AB, I have side BC, and I have side AC for my triangle. And these are going to be congruent to their transformed images. So AB is going to be congruent to A prime, B prime. BC is going to be congruent to B prime, C prime. And AC is going to be congruent to A prime, C prime. So just notation, having the prime is the image, no primes is the pre-image, and they have to be the same length if we have a rigid motion. And we'll be dealing with rigid motions today. All right, so my first transformation is a translation. So let me just note down here, a translation is like a slide. I move it in some direction for X and Y. So we can write translations a lot of different ways. I can write it with words, but a lot of times we take a coordinate X, Y, which would be my pre-image. I use an arrow, and then I represent moving it in the X direction. So some number that I add to the X, or I can subtract, and then some number that I add to the Y, or I can subtract. So this is typically how we write out the rule or the function of a translation. And a lot of times we call them with a capital T for translation, but we'll get there. All right, so I have an example here. zoom in. So I want to translate trapezoid WXYZ 4 units to the left and 2 units up to form W prime, X prime, Y prime, Z prime. We're going to identify the coordinates of the vertices of the translated image. So, closer so you can see my points. So, W is the point 1, 1. So my point W prime, I'm going to go 4 units to the left and 2 units up to form a new figure. So what I can do is just on my graph, count 4 to the left and 2 up. 1, 1, 2, 3, 4, 1, 2. So here is my W prime, which has the coordinate -3, 3. All right, and I do the same for my other points. So I'm going to take my X, which has the coordinate 4, 1. So my X prime, I'm going to go 4 to the left and up 2. So that coordinate will be 0, 3. Here's my X prime. Then my Y coordinate is 4, -1. So for my Y prime, I'm going to go 4 to the left and up 2. So that will be 0, 1. There is my Y prime. And then my Z coordinate is 2, -1. So my Z prime coordinate going to the left 4 and up 2 will be -2, 1. So translations are probably the easiest of the transformations. You can do them on the coordinate plane by counting them out. Or if I had started with some XY point, moving forward to the left means I'm going to subtract 4 from the X coordinate. And going up 2 means I'm going to add 2 to the Y coordinate. So this would be my rule for it. So if I plug in a -1, 1 minus 4 is -3. If I plug in the 1 for the Y, 1 plus 2 is the 3. So however you feel comfortable doing it, it's kind of up to you. All right, so here I have another example. And we are translating triangle PQR according to the rule. So this is given to me as a rule. I can write out the words for it. This +6 to my X means I'm going to go to the right 6. And this -1 with the Y means I'm going to go down 1 with the Y. So I'm going to do this one with the coordinates, and then I'm going to go back and plot them. So my coordinate for point P is -3, 4. So if I take -3 and I subtract 6 from it, no, if I add 6 to it, sorry, then my P prime will be +3. And if I take my 4 and I subtract 1 from it, then I'll get a 3. So the point 3, 3 is my P prime point. My Q point is -4, 2. So for my Q prime, I have -4 plus 6, that'll be a +2. I have a 2 minus 1, which will be 1. So I have the point 2, 1 for my Q prime. And then R is the point 1, 3. So my R prime, I'm going to add 6. Sorry, that is not 1, 3. That is a -1, 3. These are wasteful pens, are awesome. All right, so if I add 6, I'm going to get 5 to the X coordinate and subtract 1 from the Y. I'll get 2. So 5, 2 is my R prime. Okay. How are we doing so far? Any questions? Feel free to pop them in the chat. If you have questions as we're going, I think I set the chat to only go to me. So if you have a question about something, that's a good place to type in a question. All right, I've got one more example for translations. This time I'm going to use a function to describe how parallelogram ABCD should be translated to cover WXYZ exactly. So I'm going from A, B, C, D to W, X, Y, Z. So the letters matter how I put them in order. So A is going to go to W. So let me put those green. My B is going to go to X. My C is going to go to Y. And then my unmarked D is going to go to Z. So the ordering of my letters makes a big difference in how I organize my translations. So I'm going to start at some point, X, Y, and it's going to be shifted. So if I start at A and I go to W, I need to go to the right. So I'm going to go to the right 1, 2, 3. And then I'm going to go up 1, 2, 3, 4. So I'm going to go to the right 3, and I'm going to go up 4. So to the right 3 increases the X's, and up 4 increases the Y's. So that is my rule. Okay. Do you remember translations? Coming back slowly. All right, so translations. All right, my second one that we're going to look at today, transformation, is a reflection. So when you reflect something, we essentially flip it over a line. Now my line can be any kind of line. It can be a vertical line or a horizontal line. Those are the easiest ones to do, or it can be a line that has a slope, a set slope with a diagonal. So we'll do lots of different reflections. Something to point out with reflections, the line always goes halfway in between the points. So here I'm starting with triangle ABC. I'm going to reflect it across the x-axis. So I always like to identify my line of reflection. So sorry, I said X, it's actually the y-axis. So the y-axis is my vertical line. So this triangle is going to flip over. So my right angle is on the top right, but when I flip it, it's going to be on the top left here. So if I take A, I have some distance from A to the line of reflection. I need to do that same distance on the other side. So A, 1, 2, 3, 4, 5, 6 away from the line of reflection. So I'm going to go 6 on the other side. So here is my A prime. B is 2 away from my line of reflection. So my B prime will be 2 away from my line of reflection. Again, my line of reflection is always halfway in between the image and the pre-image. And then C is also 2 away from my line of reflection. So there is my reflected triangle, A prime, B prime, C prime. Writing a rule for these is a little bit harder because it depends on where the line is. It's not as easy as just adding or subtracting, but we can always write a rule after we do it. So if I was to write a rule for this, my X, Y, so my X here is -6 and my Y is -1 for my A prime. Sorry, for my A prime is a +6, -1. So I just need to look at the relationship. My X changed signs, but my Y did not. Let me check that with another point just to make sure. So for my C, I have the point -2, -4. And then for my C prime, I have the +2 and a -4. So I have the same relationship where my X changed signs, but my Y did not. So changing signs is multiplying by -1. So my rule here from X to Y will be -X, Y. So I will ask you for the rules for these, but I recommend actually doing the transformations first. Right, so for my next one, I have a reflection of a quadrilateral and they're giving the rule. And then I want to describe the reflection in words. So my points are going to be easier to handle here. I have J, K, L, and M. So the point J is -4, 3. So my J prime, I'm going to use this rule. So my Y coordinate is now my X coordinate. My X coordinate is now my Y coordinate. So I just switch these. So I have 3, -4. Let me go ahead and plot that point. So here is my J prime. All right, looking at K, I have 0, 4. So my K prime, I'm going to switch the X and the Y coordinates. So I will have 4, 0. Here's my K prime. My L is the point 2, 2. So my L prime is going to switch these. Well, they're the same. So L prime is the same as L. So it's the same point here. So a small hint, if your reflection and the image and the pre-image are the same, it's on that line of reflection. All right, and then M is negative 1, 1. So my M prime, I'm going to switch, make that 1, negative 1. Here is my M prime. And then I'm going to connect. All right, so my line of reflection here is not a horizontal line. It is not a vertical line, but it is a diagonal line. So the easiest way to find the line of reflection is to connect my endpoints. So, or my pre-image to image. So if I do M to M prime, I can do J to J prime. I can do K to K prime and then L to L. That's the same. So the midpoints of these lines, and we know how to find the midpoint, are going to be on my line of reflection because it's halfway in between. So this is the easiest to find my midpoint here. So I went through a diagonal. So there's my midpoint. Here I kind of went through a diagonal. I think I did. So it's going to be there. This one is on the line of reflection. So I'm going to connect these 3 points to create a line. So this line, if I think of it in terms of y equals mx plus b, we've gone through finding the equation of the line. My slope here is 1, and my y-intercept is 0 since it goes through the origin. So I could think of it as y equals 1x plus 0 or just y equals x. So I'm going to describe this reflection in words. So in words, we're going to reflect J, K, L, M across my line of reflection, y equals x. So describing, we need a verb, we need a quantifier, so that's going to be my line y equals x, and then a direction we're going to go across it. Okay. All right, I have one more example here. Let it focus. There we go. So I have triangle STUV is graphed. I'm going to reflect this over the trapezoid over the line x equals 4. So anytime you have a line where there's only one variable, so x equals 4. So this represents a line where all the x coordinates are 4. So it could be 4, 0, 4, 1, 4, 2, 4, 3. Here is my line of reflection, x equals 4. So if you struggle with the x equals 4, maybe a y equals 4, please ask. But if it's an x equals, it only crosses the x-axis and it crosses at that specific point. So I'm going to take my points one at a time, and I'm going to go to the line of reflection, and I'm going to go the same distance on the other side. So if I start at S, I'm going to go to my line of reflection with 6 away. So I'm going to go 6 in the other direction. So S is the point -2. What's that, -4? My S prime now has 10. -4, so then go up or down. So T, 5 away. So here is my T prime. So T had the coordinate -1, 1. T prime has the coordinate 9, 1. U is 2 away, so I'm going to go 2 on the other side. So here's my U prime. U had the coordinate 2, 1. U prime has the coordinate 6, 1. And then V is 2 away from my line of reflection, so 2 on the other side is my V prime. So V is 2, -4. And my V prime is 6, -4. I didn't need the points, but I like to show the points. So my line of reflection. So your assignment today is going to be on Delta Math. I have instructions on how to create an account, but it is all digital work. So the papers that I had and that I had printed in Canvas and then I had delivered. If you were a quarantine student, we may get to those, we might not get to those. So don't throw them away, but they're not the work that I want you to do today because I just can't guarantee that everyone can get them printed. So it's on Delta Math. Should we look at Delta Math? You guys want to see what that looks like?
Yes.
Yes.
Okay, so I'm still recording, but let me see if I can get it going. Oh, I didn't need to log. Actually, I have it. I think I have it on my iPad pulled up. Okay, let me get my stuff together here. Okay. All right, so this is what my Delta Math looks like when I log in. But I do have an assignment and I did fix that 4 a.m. due date. Sorry about that. But I have 1, 2, 3, 4, 5, 6 different skills that I want you to practice. You have to get 5 right. There are an infinite number of questions because it keeps repopulating. But once you get 5 right, you can move on to the next one. So the first 2 are doing translations, and then the next 4 are looking at reflections. So if I look at this example, so they want you to translate the figure 1 unit, 1 unit left and 2 units up when it focuses. And they're going to draw a vector from the origin, 1 unit left and 2 units up. So the vector is like the arrow in the direction they need to go. So 1 unit left, I'm going to start at the origin, 1 unit left and 2 units up. So it is super hard to do with fat fingers. So I'm going to make it bigger. It's probably easier to do with a mouse, but 1 unit left and 2 units up. So there's my vector that I need. And then I'm going to move the tail of the vector to each vertex of the figure. So I'm going to move this to that point. Okay. Oops, I missed it. Move it to this point and to my third point. And then it moves it for me and I can see the translation. I'm correct. I may now submit to get credit. You want to submit this answer? Yes, I want to submit this answer. And then it gives me another one, right? Or it'll give you another one. So they're all interactive. They all have correct answers and they all show you, like they go through what to do. Now, if you struggle with something, let me go back. I can ask it to show me the solution, right? Or if I click this question mark, nothing happens. Okay, so the question mark I felt like would give you another example. Maybe it won't, I don't know. So this is neat, it is cool. Don't let it stress you out, okay? I do have 3 due dates set, so it's due today at 4 o'clock to get this done. If you can't get it done by 4 o'clock today, then you can get it done tomorrow by 4 o'clock, but it'll be 10 points off. And then Wednesday, 70%, so 30 points off. So try to get it done today by 4 p.m., not 4 a.m. And then let me know if you have questions with this, if you have a hard time logging in or creating an account, all that good stuff. Okay, other questions before I end the recording? All right, I'm gonna stop the recording now.